Good evening, everyone. My name is Abhishek Chaturvedi, and I am part of Godrej Material Handling. I am very pleased to welcome you to the next webinar under the Storage and Handling Knowledge Series, which is on battery handling systems for material handling equipment. Now, this Storage and Handling Knowledge Series, as you know, has been conceptualized to become a knowledge sharing platform for all the participants, audience, and the industry in general. We have been receiving very good feedback on the various topics that we have had on this platform so far. And we would welcome your suggestions and your request if you want us to cover anything related to the material handling or the storage domain. Today's topic is very relevant to the times when people are looking at process optimization at every stage. Now, one of the key productivity improvements that people look for is in terms of handling of batteries of material handling equipment, the changeover time, the ease of battery handling. These are factors where people really, if they're able to optimize their processes and have mechanisms where they can squeeze the time required in that and optimize the space, it would be a big boon for any industry having large fleets of equipment and equivalent batteries. So considering the topicality of this particular aspect, we are very pleased to have Mr. Trent Booth as the expert taking us through the various battery handling solutions which are available in the market. Trent is a veteran in this field, having more than 6 years of experience in offering customized battery handling solutions to customers across the globe. I think it would be a very insightful session for all of us once we go through this session by Trent. One small request, please put in your questions in the chat box during the course of the presentation, which we will cover during the end of the session in about 50-55 minutes from now. The last 30 minutes have been allocated for answering all your questions that you may have on this topic. Another small request, at the end of the presentation and at the end of the Q&A session, we'd be very grateful if you could fill up the feedback form. That would really help us to improve further, or we'll be able to understand if you have any request about the topics that you would want to cover in forthcoming sessions. With that, I would like to request Trent to take us through this very important topic, battery handling systems for material handling equipment. It's all yours, Trent. Thank you.
Thank you. So as discussed, we will be covering battery handling systems for material handling equipment. So as BHS, we are one of the manufacturers in the world that help deliver some of this equipment. So what we'll be mainly going over is what this type of equipment is and how it can assist in forklift battery handling and warehouse equipment solutions. We'll also be covering the BHS battery room best practices. So this will be a collection of our different recommendations and knowledge that we have seen throughout the industry that help with the room design of it, the application of removing and storing batteries, or even charging individual trucks as well. Along with this, we'll be also covering the different safety programs and the management training that will be needed in order to properly run a battery room. This will also include some different inspections and proper operation of the equipment itself. With battery handling equipment, there's three main ways of handling or dealing with the charging of the batteries themselves. There's what we first start off with, which is the side extraction. This consists of either carts and carriages that are independent or mounted on a pallet jack type system, or what we call our operator aboard battery extractors, which are driven by an operator on the piece of equipment. Next is the vertical extraction. This consists of battery lifting devices that are independent of themselves, and then finally gantry crane systems that are used to lift these batteries vertically out of a truck in order to remove them. And finally is the park and charge applications for the fleets that do not need to change their batteries out. There is multiple equipment offered to be able to store chargers and have trucks pull up to them and park in and charge. This is an overview of a battery room, kind of showing all the different types of products and things that can be involved in a application. Now this one is a little bit more shown towards the park and charge and the smaller change-out fleets. So I'm going to go ahead and run you through a few of these equipment with a little brief overview. So starting off in this, right about here, we have the charger wall brackets. These type of equipments when you're storing chargers, and it's more in line with what we call a park and charge application. This is where the truck will pull in and plug into the charger and approximately charge, depending on if it's a fast charge or not, for 1 to 2 hours up to 8 hours. So there is no handling of the battery itself. Next, going down here is the typical change out. So we have two different ones shown. So in this left corner right here, we have an application used in a man or operator moved battery extraction device. Or over here on the right, we have one that is one that's mounted to a pallet jack that is electrically operated. Both of these are set up to be able to pull the batteries out of the side and then put them back into a stand for charging while being able to retrieve and put a fully charged battery back into it. Some of that equipment that's involved in that type one is the battery stand itself, the battery transfer carriages, what we call an automatic transfer carriage, but an electrically powered transfer carriage mounted to a pallet jack, another type of battery stand as well. When all of this type of equipment, there is different maintenance things that will be done, and we'll go a little bit further in depth with them later on in this presentation, but there is wash equipment. These are different equipment designed to wash the batteries, consisting of roller wash stations, recirculation units, and changing a battery. And once again, there's different management solutions as far as how to know when to change a battery. So we do have shown here some of the things regarding Eyewash and some next available battery. And then the different items that you can find related to safety and maintenance of the batteries throughout the room, with the hydrogen exhaust, the water filtering system, equipment cleaning kits, shower eye washes for safety, signage and posting, spill kits, water guns, perforated pads underneath in the drip pans themselves, guardrail to protect the equipment, epoxy floor, and another protective rail to protect the equipment. As you can see, there's lots of different items that can go into a battery room depending on the different applications. So with the side extraction method, there are a few different types of carriages that can be used throughout the industry on it. You have carriages that are totally self-contained and a power drive system and a powered extraction, to where it actually will reach out a vacuum cup or a magnet type assembly to grab onto the battery to pull it back in. The ones that are what we call an automatic transfer carriage, but the ones that are dependent on a pallet jack themselves, still with a electric extraction type, to another one that's mounted to a pallet jack but now has a manual extraction for your lower volume applications. And then finally on this one is a pushed around extractor that can either be a manually operated or electrically operated for the extraction. Some other solutions that we see more common with the smaller battery sizes, mainly in the type of pallet trucks or pallet jack type trucks, dual transfer carriages that are mounted on them, bridge trolleys, which are more of a manual type solution, and then finally some of the manual rolling carts where the battery is physically pushed onto the cart, pushed around, and then pushed back off. I'm going to take some time here to show you a video by Chuck Ray, one of our other industry experts who's actually been in the industry over 42 years, and he's going to explain a little bit more in depth on how an automatic transfer carriage works and some of the features of it. Apologies, that one does not seem to be playing. Apologies on that one. We will come back to that video later. Next, we are showing a typical of the larger size battery rooms. This one is more in line with the operator boarded battery extractors. We are storing a greater quantity of batteries, typically in the 100 to 400 battery count range. Still going to have a lot of the similar type equipment that's in there, but some of it's going to be a little bit different. So starting off with these big ride-on type battery extractors that allow the unit to travel back and forth on this aisle and actually go up vertically and be able to pull batteries out of the rack itself. This will also comprise of the rack, which can have ventilation type equipment in order to extract the hydrogen gas, which we will discuss a little bit further. Different type of electrical options, always backup solutions, because machines are machines. They do have the potential to break, so a backup solution is always good when you're depending on one of these. Different type of servicing equipment to maintain this. Barrier rails, again, of course, to protect this valuable asset. The battery stands. Portable gantry cranes, so if we do have a mixed application that is using side extraction where there are rollers in the forklift itself, but then also maybe some of the trucks need to be extracted vertically, you can also incorporate different cranes into this type of system. The wash equipment, the recirculation on it, along with the cabinet itself that washes it, and the wastewater one, we will go more in depth in that as well. Different safety options, fleet management options to ensure they're picking the correct battery. Epoxy floors are always good, and once again, a little bit more details on that further along, and then signage and posting. So as you can see, even in the two different types of battery rooms, there's a lot of equipment to consider and to make some smart solutions on. Next, we're showing a little bit more in depth on the actual operator board battery extractors. As you can see, the operator stands on one end of the extractor and then drives it with different types of control mechanisms. From there, and this is very similar across the entire industry, is you will have a cart that consists of two different roller beds with some type of extraction method in between. This one's currently shown with a vacuum cup on it. So from there, they are able to drive this cart forward and backwards, depending on the rack layout. Racks could either be laid out on the right-hand side and the left-hand side, so on both sides, or they could only be on one side. They will be able to then select a battery from the rack, go back to the forklift itself, pull the battery out of the forklift, and then take that new battery that they have on the extractor and deposit it back into the forklift. At that point, the forklift is free to go, and they are then able to take that discharge battery and put it back into the rack so that it can be charged. And what's typical of a conventional charging cycle, which can range 6 to 8 hours long. Some basic guidelines on them, and these are just guidelines. Everything depends, space constraints, actual throughput through the system can all change up these, but good general guideline: 1 to 99 batteries, a single high system is good. 100 to 149 a double, 150 to 299 a triple, and finally over 300 systems a quad or a 4 high stacking system. Now those are guidelines. There is the definite potential to be able to use a 3 high system with as few as 30 or 40 batteries. It really depends on how that battery room is laid out and what type of space is available. As you know, same thing with pallet racking. The higher you go, the less the overall space that you take up, and the same is true with battery racks. The average changeout time with this type of equipment is about 2 to 3 minutes. It's a lot faster than the other ones. As we'll see, the transfer carts themselves that are mounted on pallet jacks or driven by just individual operators pushing them can be in the 5 to 7 minute range, versus a gantry crane system or any type of crane system lifting a battery overhead vertically, due to the extra caution that you need to do in order to go a little bit slower and be safe, can be in the 10 to 14 minute range of how long it takes to do a changeout. So customers that are looking for a lot faster of a changeout type solution, or your facility, the operator board battery extractors do help that with that. They are offered with two different extraction types, vacuum or magnet. There's been a lot of discussion throughout the industry regarding vacuum or magnet, and I'll share a little bit of experience and what we've learned in the United States market regarding this. So back before when forklifts were first coming out, a lot of the batteries were of a lot bigger size. Most customers were using the bigger sit-down style trucks that had the larger batteries in them. These batteries could be, sorry, I'm using an imperial measurement system, but they could be 36 to 42 inches wide. They could weigh almost 5,000 pounds, more typical in the 4,000 pound range. And with that, the magnets were not always strong enough to be able to pull them, so most users ended up having a vacuum cup on it. A vacuum cup has extremely high pulling force, sometimes up to 1,500 pounds of just grabbing force to be able to pull those batteries out of those trucks. As the years have changed, and everyone knows, the trucks have gotten smaller, the batteries have gotten smaller, less reliance on the four-wheel type sit-down trucks that have the big batteries in them, and more going to what we call stand-up trucks where the operator stands up on them and services. What that has done is shrink the batteries quite a bit to where you now have batteries that are probably on the big side at 21, 24 inches in imperial, and right around 2,500 pounds. And with that, the magnet is now able to actually grab them. And the reason to switch to the magnet versus the vacuum cup is, as operators sometimes use the vacuum cup when it's attached to a battery, they will make small adjustments during the changeout process. And with that rubber on the vacuum cup, that could cause it to tear, which then really leads to problems where they have to replace those vacuum cups constantly. With the magnet is a lot more durable solution and resists that type of damage and allows for some adjustments as it is attached. It is always best to detach it before with any of the pieces of equipment, but sometimes mistakes happen and this just helps avoid those a little bit more. Typical capacity on machines is upwards of 10,000 pounds. A lot of that is due to the older battery designs where they could be up to 5,000 pound batteries. And this allows that machine to hold two batteries at once. And by holding two batteries at once, that is where it gets that faster changeout time from. Compartment widths can range from 24 to 36 or even 42-inch compartment machines. But as I said, the battery sizes have gone down quite a bit now throughout the time, so the 42s are a little bit rare. Very important when looking at this type of equipment is making sure that there is a really heavy-duty extractor arm design. That extractor arm is the key part, the heart of the system. It is what is needed in order to pull those batteries and push them back into the racks. So having a heavy-duty extractor arm is important. Having a capable lift system, as you know, those battery rates still at 2,500 pounds, that's 5,000 pounds of weight, which sometimes gets more than what a lot of forklifts can do. So having a very capable piece of equipment that can lift up those heavier weights and then do it over the long term and last is really good. Same thing with downtime prevention. This is a key part of your operation if you go to this style. You only usually have one of these machines. Maybe some applications will have two or three, but usually spread out. But it is a key piece of equipment, so it is best to always look for something that's going to be easy to maintain and to prevent that downtime. Some of the great features to do, and one of the common failure points is the drive wheel system. These machines drive in the exact same path every single time going up and down the aisle. They do not have steering wheels on them. They do not turn side to side at all. They always go the same place. So the drive wheels are a common failure part of them due to that type of application. So making sure you find a product that has a really durable drive wheel or even dual drive wheels as shown here. And then multiple safety features. Of course, safety is always main objective. So having multiple safety features, be it different systems to keep the unit from being able to fall down if a hydraulic was ruptured, or keep an operator from unintentionally maybe pushing a battery off to the side. Very good to always have multiple safety features on these types of pieces of equipment. Next is kind of an overview showing the few different models that are offered out there of different type of extractor systems, operator board extractor systems. So single-sided one, this is an older design that's primarily used only with single high stands, so one level, and then only pulls them out on one side of the system. It makes for a very compact floor plate, so very small, but does have a slower changeout speed due to it not having two compartments. And then finally, some pictures of the different level ones with the 1 high, the 2 high, the 3s, the 4s, and then some even that can swap into the different competitor type systems that are out there. I'm going to get this video to play here for you real quick.
Trent, sorry, but we are not able to hear any sound. Trent, are you able to hear me?
I'm sorry?
Yeah, the video does not have any sound. Is that so?
Sorry, it was playing on my end.
So you can just maybe just explain a bit about that because we are not able to hear any sound.
Apologies. So what this was doing is it's showing an overview, and it did have some good text icons showing that, and I'll try to make sure the sound works on the next video. And it's just showing the overall of how one of these extractors operate and remove and discharge the batteries from the racking itself. Let me mute the sound on my end and then kind of walk everyone through it real quick. Now it's showcasing the different safety items and accessories that you can have. So apologies for the sound. So that was a visual overview of how a operator board battery extractor works, along with some of those accessories that we were discussing earlier and what they are doing there. Next is the gantry type system. So quite a few years ago, almost every single type of forklift used what was called an overhead extraction method of removing the batteries. The side doors on the forklifts might have came off, but they didn't come off enough that you could actually pull the battery from the side. And the top guard was cut out to where a hoist, a chain, could be able to fit through it to pull the battery. So by doing this, they did an overhead extraction where they'd use what we'd call a battery lifting beam, which we can see right here attached to this crane, and they would attach this to the battery and then lift this battery overhead out of the truck, place this on a rack, and then they would grab the charged battery, pull it out of the racking, and place it back into the truck itself. For guidelines as far as what type of application would need this, of course, if your trucks are only vertical extraction, they do not have the ability to pull them from the side, this would be a solution. And as long as the fleet size can go from 2 batteries or more, anything under 2 batteries, you can actually use what's called a fork attachment, which allows a forklift to be able to pick up a battery lifting beam safely and use that to transfer batteries, because under that many you will not be transferring that often. Otherwise, these gantry systems can go over 200 batteries and can take up quite a bit of space if needed and take care of a very large fleet. As I said, the average changeout time is 10 to 12 minutes, and as I kind of described the typical process, there's a lot going on there, and speed is not the best thing to do with this. You want to be very slow and cautious, as you do have a potential 1,000-pound to 5,000-pound load suspended in the air. The capacities of these cranes can go from 4,000 pounds to 6,000 pounds. Some of the requirements for them is there's floor track that's needed. If it is a power drive type system where the crane itself can physically move back and forth across the stands in order to place those batteries, there's track that's needed. Of course, a battery lifting beam is going to be needed in order to attach and properly secure to pick up those different types of batteries. A hoist and trolley kit, this is the hoist right here that is shown in order to lift those batteries up. And then also the trolleys can be powered, which means that instead of having to pull this physically to go from what we would see as the left and right here, there will be a power to where you could press a button and actually move it in here and make it a lot safer and easier on the operators themselves. The gantry system, due to the controls, as we can kind of see this little yellow control box right here, does allow for a one worker operation. So from there they are able to press the different controls to raise the crane, which raises the beam, be able to move the hoist itself left to right, and then also to make the crane go back and forth through the stands. So this can be done with one operator. We just discussed the operator controls, and they are very customizable. There's a few different applications. It can be based off what type of, how many batteries are we trying to store, what type of trucks are there, and then of course one of the most important things that comes down to all the design with all these systems is what type of space is available. Is it a very small room where we need to use smaller cranes? If not, if it's a bigger room, it's always better to go with the bigger cranes, as it allows more free space in there to aid in a safer operation of removing the battery from the truck itself. And of course, all these systems are always modular, so as needed, you can always add on additional track and battery stands in order to increase your storage capacity on these systems. Next is kind of showing some of the different types of battery stands or even park and charge or charger stands that are out there. Shown as a picture showing the 4 different models of the stands. So we have a single level type stand, a 2-high stand, a 3-high, and a 4-high. One of the big differences all across the industry is, and of course with these models that we're showing, that these are capable of holding drip pans, which we'll talk a lot more in the future about, but one of the important notes on it, it's due to their leg construction type. Next are what we call the threaded rod stands that are out there. So these stands are a little bit adjustable, so they can be adjusted based off the floor conditions and do not require shims like the blue stands, system stands shown here. But they are not drip pan compatible due to having threaded feet on them. There's nowhere to attach them. And these also do include the gantry stands, which have a little bit of an exception in that they have welded feet, but do have the capability of holding drip pans in them. And then finally are the charger stands. As charger designs have changed quite a bit throughout the years, going from the bigger, what we call box style cabinets, which could be up to 3 foot wide, 300 pounds, and they have moved on more to the wall mountable high frequency chargers, which get down to sometimes even 10 and 20 pound range and only are 7 to maybe 12 inches wide, a lot smaller of a footprint. So as that time has changed and how those are mounted, charger stands designs have changed with them. So it's always important to make sure you have the correct type of charger stand for the type of chargers that you will be using. Determining the location of the battery room is probably one of the most critical pieces of these type of projects. It is very important to make sure to locate this room to where it is easy to use with the different traffic aisles. So you do not want a type of room, and I've seen them a few times out in the field, to where as the trucks are maybe coming in to get the change out, or if there happens to be a line that develops due to the change out times, that they are not blocking one of the main travels aisles, leading to the entire operation at the facility to slow down. You want to select a room that has an easy entrance and exit in order to get the trucks in and out of it. Also, as you've kind of seen, there's a few different solutions. So based off the space that is available, what you need to hold, there's a few different types of products you can use, but you want a room that allows a adequate space. Typically, what we kind of look for is around 50 foot by 20 foot, should usually take care of about most of the size fleets that are out there. Anything smaller than that, especially with the operator board extractor systems and the gantries, and a lot of times those applications can't just get that small due to the extra space needed as they travel. Having a centrally located one is important as well. So it's one thing to have a fast changeout time of 2 to 3 minutes, but if the forklifts have to travel from the far end of the building to the battery room, and that takes 10 minutes doing it at a safe, stopping at the different intersections, it does not really matter what the changeout time is because the operators had to drive so far. So in some applications, it's even better to have multiple battery rooms located throughout the facility or in a central location. So if there are docks on both sides of the warehouse, doing a battery room in the center of the warehouse will minimize that time that they would have to travel for both sides of the warehouse. Some applications, the warehouse is just so big or the certain spots are spread out between them to where they would have multiple battery rooms. In this type of scenario, I've even seen it where we get more truck specific and only tailor that battery room for that type of truck. So if there are maybe a lot of sit down type trucks or what we call the stand up counterbalance type dock trucks, only on the dock side of the warehouse, there could be a battery room that specializes in just holding those type. Versus further on in the warehouse, maybe it's just racking and there are no docks on that side. And then that one would mainly just hold the reach trucks type batteries or even the pallet truck batteries that are used there. So a few different ways, and it really depends on your application, but that's some of the points to look at when planning your battery room. Next big important piece, and a lot of times during the projects I've encountered and experiences, it's one of the last things people think of, but it should be one of the main ones you think of. And this is the electrical requirements. As you know, batteries are electric and do require a way of getting that electric back into them. And that is done by using the battery chargers. Once again, talking about from experience over time to what we do now, quite a few years ago, the electrical requirements on the chargers could be upwards of the AC requirements could be 10 to 20 to even 30 amps that are required in order to power that battery charger itself. Over time, this has came down, but still can be quite a bit. If you imagine, even on a old one, you have 120 amp chargers, that's 2,000 amps of power that is needed in order to power those chargers. That's some really big feeds, and that would be a lot of the main power consumption of a typical warehouse. So it is very important to know what power is going to be like going into that battery room and planning for that in the design of the building. Now, of course, as the chargers have gotten smaller down to 7 amps, you take in consideration now to do 100 of those would only be 700 amps. Still, 700 amps is quite a bit of power that's needed for one area, and way more than any type of single piece of equipment that I've seen. So planning for the electrical is really important. There are a few different types of solutions out there. There's different type of bus rail systems that is shown right here, which allows for single input feeds, saves a lot of time with the electrical because it's a prefabricated, pre-built type of item to where all they were going to have to do is the electrician will run into this one line feed into it, and then all the individual chargers can hook into it. There's even what's not shown, but what's called power panels, which are single input devices that can have outlets from 4, 6, or even 8 outlets on the panel itself to help with that electrical requirement. Still consider that that main power supply is needed, with some of these systems consuming up to 10 or 2,000 amps of power, and typically at 480 volts is what we see, 3-phase power on it. Next thing, as far as the charger stands themselves go, so depending on what type of charger it is it the newer styles that can be wall mounted, or is it the older cabinets that need to be on a bracket in order to be wall mounted? Or to the older cabinets that are in a higher density, so a operator board type extractor system where we're storing batteries vertically. We can't just store the chargers on a single level. We need to be able to store them vertically as well with a multi-tier type charging solution. And to always remember cable management. It's very important to consider what's going to happen with what we call the DC side cables, which are the cables coming from the charger to the battery, and how to deal with those. Typically, those can have a length of between 8 to 16 feet, depending on the application of them. So it's important to know how to have those cables properly routed, as you can see in this one photo, how they're coiled neatly here, or even using what's referred to as a cable retractor that allows the operator to pull that cable down, plug it into their truck or their battery, and then when they are done, it will actually spring back and pulling that extra slack out of that cable and keeping it off the ground to where it doesn't get ran over. It's very common to see the forklifts hit these type of cables, damage them, damage the connector on them, or even in a changeout type system to where the cable dangles and then gets pinched by the battery itself against the racking. Throughout parts of the world, we all know there are earthquakes and different things that happen. So when you are dealing with a multi-high system, so in the US, anything that we deal with over 2 high in certain areas of the country has to have a seismic rating. So it's important to make sure that those battery stands or even charger stands that you select do have a seismic rating on them and are able to withstand that when properly installed and anchored. Next is battery room floors, and I'll refer to some of the standards that we do have in the United States on it. We have a body called OSHA, which stands for Operational Safety and Health Administration, that does a lot of the rules regarding workplace safety and taking care of the workers. And one of their rules say that the floor shall be made of an acid-resistant construction and less protected from acid accumulations. What this means is that the floor needs to be made of having acid-resistant epoxy coating on it, or the battery stands need to have a protection system in them, drip pans fit that, to keep that acid from going down. Lots of people might be wondering, why would I have acid and stuff in there? So inside of a battery is a combination of water and acid. Now, over time, as the battery is charged and just through being sitting there in the hotter environments, it's going to evaporate and that water level is going to be reduced. So one of the maintenance items is to water the battery. That is to fill it back up with additional water to bring that level back. The acid does not evaporate, it stays with the battery, but the water will. So they water the battery. A lot of times, this is done at the inappropriate. So when a battery needs to be watered is after it has been charged, because during the charging process, or as a battery is discharged, the acid is sucked into the battery plates themselves, which lowers the level. And as the battery is recharged, that acid is pushed back out of the plates, which causes the water level in the battery to rise. So if an operator, for example, watered a battery before it was charged, that would increase it. Maybe we'll say it's at the full level, but then once it's charged, that additional acid is pushed back out of the plates, causing that water level to be too much, and then it actually boils over or flows outside of the battery. At that point, that water will contain acid and lead from the batteries, which then will pose a hazard to people in the battery room, as well as can damage the battery stands themselves or even the floor. So that's why this rule was made for the epoxy floor or some type of drip pan, and it's also why BHS offers drip pans on all of the blue system of stands. In addition, one of the equipment goes a little bit more in detail is what's called type of pillows or aft absorbent material. A lot of drip pans, and I've seen it a lot in the field. It's a neglected item. They're there, they catch the overflow. It's going to happen. Operators are eventually going to water batteries at the inappropriate time, and that drip pan's going to catch it. And then it becomes a hazardous mess. So the thing to consider is doing some type of perforated chemical absorber in there, some type of pillow that maybe has an acid absorbent or a neutralizer in it in order to take care of these type of problems. Next is battery room ventilation. So with a battery, as it is charging, typically when it gets above the 80% point as it's being charged, it will do a thing where it produces a hydrogen gas. Now, a hydrogen gas is an explosive gas, and it's also colorless and odorless, so you cannot detect it just by a person. You have to detect this using sensors. And it is a common thing with batteries as they're being brought above the 80% point that they're going to off-gas this and have this hydrogen. Now, there's quite a few factors that go into how this will be in the room size or even the count of batteries, which I will show you on a calculator, takes this into consideration. So for example, I'm going to bring up the calculator and show you what a typical one would look like here. So this is a battery room calculator, and I'm going to keep it a little bit simple here. So we're going to put in some just kind of generic numbers here. Let's see. So this right here, what I've done is I've plugged in the specifications of our battery. We say it's a 36-volt battery, 750 amp hour rating, and then 100 batteries itself. Next, we put in the room. We'll say we have a 50-foot by 100-foot room, maybe a typical warehouse ceiling height of 40 feet. And there we click calculate. What this does is gives us kind of a worst case scenario on the amount of hydrogen that will be generated on this system. So we see that 994 cubic feet of hydrogen gas is generated per hour. And that after 1 hour in a room that is 100 foot by 50 foot with 40-foot ceilings, the concentration will only be at 0.5%. So based off that, it recommends a different type of or how much ventilation you would need in order to cycle that air out. So in order to complete an air exchange every 121 minutes, an exhaust fan would need to be 1,653 cubic feet per minute of air movement. So there's quite a few things that take into account, and a lot of times in typical battery rooms now, they are not sealed off rooms. We're starting to see a lot more where they're open to the warehouse. So it's very important to have especially a fan in that application due to operators will perceive it as a hydrogen smell or as hydrogen, but it's really, they're smelling sulfur, which is not hydrogen because it is odorless. It is just another byproduct of charging batteries. So a few different types of equipment or even the built-in ventilation systems on battery stands where exact ducting is ran to all the battery compartments on there to extract that hydrogen from it, to in-wall fans that kind of take an overall approach, pulling the air and cycling it out of the room. And then also definitely recommended is the hydrogen gas detectors. These detectors can sense that hydrogen, and through their circuitry that is on board, they can do a few different things. So a common one is a dual relay model, which has two relays in it, one that activates at the 1%, and then one that activates at 2% plus sounds an alarm. So for instance, at the 1% level, you can have that trigger the fan so we can go ahead and get that level back down. And then if for some reason the fan did not kick on, or a lot of batteries are just producing a lot of hydrogen, if it increases to that 2% threshold, at that point it could trigger additional fans. You can even have it wired to where it turns off the battery chargers themselves. Plus you'll have an alarm, and you could even have it have maybe a remote alarm in the manager's, the director's types offices, so that they know that there's a problem going in the battery room. It's very important in order to include those. Going to show you another video by Chuck Ray, kind of explaining the hydrogen exhaust fan kit.
Trent, there is no sound.
Sorry, are you able to hear the sound this time?
No.
No sound still. Apologies, as this was working earlier. Were you able to hear it that time?
No, it can't actually.
Not sure what is happening here that's keeping that sound from going. Give me 1 sec, let me try this.
You on the sharing button of this platform, you may have to share system sounds. There's a tab on there. So using that, you can share the sounds on the Teams platform.
Okay, sorry on that. I will I'll just talk over the video and kind of explain what he's saying. I'm not sure why we're not getting sound and we were getting it before. Chuck right now is covering the hydrogen gas detector, talking about where to actually place the hydrogen gas detector itself so that it is mounted in the top end of the warehouse as hydrogen gas does rise. Showing the different lights that are on there regarding the two different relays that we discussed, with a warning light at the 1%. And then when it hits the 2%, there is an additional light, a red light, that illuminates. This model has a built-in alarm at 80 decibels that then sounds on the 2% relay. You're showing the hydrogen exhaust fan kit, which includes the exhaust fan and a hydrogen gas detector all in one rooftop. With this hydrogen exhaust fan, there are 4 different fan motors, but the rating of the hydrogen exhaust fan is based where if one of the motors was to fail, the other motors should still operate and are sufficient in order to ventilate the room itself. Now he's going over the hydrogen gas, or the hydrogen calculator that we just reviewed. A few extra features on this too. With the hydrogen exhaust fans, and gonna depend on the local municipality or regulations that are in place, but it's important to know to have dampeners to maybe stop airflow from going out of the building when the fan is not working. And then also this one includes what we call in the States a fireman disconnect. So if for any reason there's a fire alarm that was tripped, there's an additional circuit on this fan that can be activated that closes that fan off to where it is not able to let air flow back into the building, which would feed the fire itself. Safety shower and eye wash stations. So it is very important, and it is actually a requirement here that we have safety stations when dealing with this. As we discussed, the batteries are full of an acid water mixture with lead plates. So one of the regulations that we have is that the eye wash stations must be accessible within 10 seconds. And what this kind of gets down to is about a 55-foot rule. But it's very important on the placement of those. When we design a typical operator board, battery extractor system, or even more of the transfer card gantry type systems, is we're looking at where is that operator in relation to the room. So on a operator board extractor system where there's a compartment that they stand on, we actually put the shower eye washes on that same side. And this helps with the next set of kind of rules. You need to provide a clear path for that operator from that battery handling area where they're changing the batteries, plugging in the trucks, to that eye wash. You do not want them going up and down different sets of steps or having instructions they have to go over. They don't need to be opening doors or stepping over items. As you know, if something's that bad that they need to use the shower or the eye wash, they might not be able to see or might be in some pain or have extreme discomfort by having that type of item on them. So it's very important to include that. In the States, we always have to have at least one shower and eye wash combination, not just an eye wash or not just a shower. It has to be a combination unit, as many different things that happen. This allows them to get the acid off their body and their clothes, as well as be able to flush their eyes if an accident did happen. Important design when looking at these shower eye washes is that they need to be in a well-lit area. They need to have shut-off valves in order to stop the water flow after they pull it and activate the system. It's good to have a type of dust covers, especially over the eye washes, as they are positioned vertically up and can accumulate debris over time. So having a cover that then only moves away when the water is activated is very advisable. And the activation is important too. Generally, you can see it a little bit here in this section right here, is that they'll have a pull down valve in order to activate the shower, or even when a big button they can push with their hand in order to activate the eye wash station. Some applications want to go even further, and besides just having a shower and eye wash, they like to also install a portable eye wash system. So this one is a gravity fed type system that then when they pull this yellow down, it's going to gravity feed the water and be able to spray into their eyes to take care of that. This one's also what we call our battery emergency station, but has a few additional items. It has this protective kit. Well, we'll leave that video alone on Chuck, but what he'll go in is to discuss the different protective kits to where the type of items that you need. Very common to have the need for the booties to go over your shoes, an apron to protect the front of you, a face shield, of course, to protect your face and your eyes, gloves as you're going to be handling this. This is battery acid. You don't want to leave it for a long time on your skin, or if you have a concentrated one, it's definitely going to hurt on your skin. And then even goggles as an additional safety. So that kit includes all those protective items. Next is battery spill kits. So of course, when dealing, we're getting into the safety of the battery rooms even more, is having a spill kit. Accidents will eventually happen. Unfortunately, it's just part of the nature of everything goes in any type of operation. So having a spill kit on hand is required in the States and definitely important. Within a spill kit, you want to make sure that there are a good assortment of different items in there to take care of it. One of the things is having an acid absorbing and neutralizing agent. So you want something that you can spread on that spill or even surround the spill that will absorb it and even neutralize it. Some of the products on the market out there now have a color changing indicator to represent when it has taken that acidic pH level and brought it more to a neutral level. One product we know of that does it starts off when it first contacts acid, it's kind of a yellow color, and then as it neutralizes it, it will actually turn to a purple indicator on it when it reads between the 6 and the 8 on the pH level. Making sure all that chemical is absorbed or even neutralized, and then making sure to clean off and neutralize all the acid that would happen from that affected battery, be it from overwatering, a spill, maybe even a damage of the battery itself which caused this. And taking care to wipe down all those exterior surfaces to remove all that acid residue. Definitely important to make sure there's a full report done documenting what all happened and maybe even what led to that problem so that the proper procedures can be maybe implemented or ensure corrective action was done to make sure that doesn't happen in the future. And with any battery room, there are multiple different sizes of spill kits that are available. Good rule of thumb I like to use is typical 6-gallon, 5-gallon kits are good for about 5 to 20 batteries. 20-gallon kit will take you from about 20 to 40 batteries, and a 50-gallon kit will take you 50 to 100 batteries. At that point, if you get over 100, we would recommend multiple spill kit options. Another thing that's very important in battery rooms is signage and posting. Different type of equipment showing the different signs and items that will be needed to point out the different safety areas or problem or protective gear that is needed in the room itself. Battery wash equipment. So batteries do have, as we talked about, they are going to get dirty being in a forklift, being in a warehouse environment to where they accumulate the dirt on the outside of them. And also during the battery watering procedure, if someone waters at the wrong time, there's going to be some that acid that might come over on the top of the battery, or even during the normal venting of the battery itself. If it is not a sealed battery, they're going to need washed down. Few different solutions as far as dealing with this, as far as washing them, but then also dealing the water, which we'll cover first. So that water that is used to wash batteries technically becomes a hazardous waste at that point, because as that battery is giving off that water that's in it, it's going to contain the lead and the acid, which is not good for humans as well as for dumping down into the drains. So a few different solutions as far as dealing with that is to have a recirculation unit which stores that water and filters it and allows for use typically between 6 to 12 months of use before it needs to be disposed of by a wastewater company that can properly take that water out and dispose of it. Another thing is to invest in a on-site solution, which we're showing 2 right here. These solutions are smaller in scale, but are able to actually effectively treat that water to the point that it is safe to dump it down the drain, or to even reuse that water indefinitely, saving money on the water bill and minimizing the waste of water itself. With wash cabinets, a few different solutions with it. There's manual stations where the operator will manually clean off the battery using scrub brushes and spraying it, all the way to the automatic systems, which will take the batteries in, spray them down automatically, and even dry them and scrub the bottom of the battery, and then give you back a clean battery. It's very important to have a strategy for preventive maintenance. There are items that need to be done on a weekly and monthly and even quarterly, yearly basis. It's very important to always check the electrolyte levels and the water levels to make sure. Batteries that are not properly maintained with their water levels will suffer damage over time of them. Make sure that the batteries are clean and maintained and all the cables on the top are in the proper condition. And then also provide an equalization charge with ample cooldown. An equalization charge allows that charger to take every single piece of that battery, because batteries are representative of multiple cells, and bring them all up to the same voltage, which helps restore some of the capacity of the battery from use over time. Monthly tasks definitely give it, once again, a look over for any kind of a damage on it. Make sure to clean that battery off, taking care of any of the acid accumulation on it. Also very important to measure that acid level and make sure it's maintaining there, and then also in combination make sure that water level is being maintained as well. Finally, every 3 to 6 months, good idea to take care of those batteries and wash them. As that type of, you'll see over time on batteries that are not kept in a good washing cycle, a white corrosion will appear on top of the battery. If this corrosion actually gets in between the different cells of the battery, this can actually start to deplete the battery's charge just by sitting on the rack. So a charged battery that was charged the night before, when an operator goes to grab it the next day, could be at a lot less of a charge, 80, 50% charge, just because of how bad the corrosion is on top. So it is very important to do that, as well as it maintains the metal case that holds the battery, providing a longer life to the battery itself. A few different solutions for watering is using maybe the onboard watering strings you can see here being demonstrated, to watering carts that allow a portable water supply to be moved around, that then a watering gun can be used if there are not watering strings on the battery in order to refill the water on the battery itself individually. This one right here was a AC powered, so it's actually plugged into an electrical outlet to power the pump on it, all the way to this what's called a bladder diaphragm style tank that is pre-charged with air pressure and then taken to the different sites in order, or battery locations, in order to push that water out of the tank and into the battery. Continuing that strategy of having a preventive maintenance, it's very important to have fleet management. Any type of battery room is a good size investment into the batteries, the chargers, the racking, the handling equipment, and even the electrical. So having or considering a fleet management solution, something that will tell your operators which battery to grab. Otherwise, a common thing is in the battery rooms is that the operator will grab the battery that looks the prettiest to them, and that will be the one that they use. What that does is that causes that one battery to constantly be used, and it becomes a bad one while your other ones are just sitting there not getting the proper use and cycles. So a fleet management system can overcome that by making sure that the batteries that have been in the rack the longest are the ones that are being picked next, as well as it can also track the different maintenance operations. So the watering of the batteries, the washing, the equalizing, helping you manage that schedule of maintaining your fleet. Battery wash equipment we just discussed about, and the water in the battery and the maintenance sprinkling, which this system will help remind the operators, and can also provide, a few of the systems out there provide reporting too. And with that reporting tool, besides looking at the maintenance and telling them to overall rotation of the batteries, it can also provide some guidance regarding, do you have enough batteries? Do you not have enough? Which ones are being cycled the most? What are the most common batteries that are being picked? What time of day are they being picked? Is it too many all happening right when the plant first opens and nothing happening at night? And so be able to help to plan that better traffic pattern out in your battery room. With that, on our website, we do have preventive or planned maintenance inspection reports for all of the different equipment. Very good that you picked a vendor that has those type of offerings. I'm going to show you one here. So we'll go into, let's use one of the ATC here. So our automatic transfer cart pile jack mounted. So just showing the different type of stuff to look at. So visual inspections on it, checking the electrical. It is a hydraulic powered system, so checking over the hydraulic system extractor. Very important that these are done on a daily, weekly, even monthly basis to make sure that equipment and any damage is noted ahead of time and taken care of, so that they can potentially minimize the repair work that is going to be done, need to be done by taking care of it earlier. And then finally, some additional information regarding at least the BHS side is we do have our BHS app. On that app, you're able to access the full website, all the videos, complete with sound, the maintenance reports, and then even some additional help if there is needed on it. There is a battery room survey that's available. Let me go ahead and show you this one here. So battery room survey is a very good tool if you do have an existing battery room or looking at a new one as far as an inspection of what all is needed. So it points out the different items, drip pans, tells you what type of products to look at, spill kits, safety protection, eye wash and shower stations, battery and safety signage, hydrogen gas monitors, ventilation type systems. Is there a fan? Is there ventilation? Carbon monoxide and smoke detectors, fire extinguishers, and then finally battery maintenance, training programs to prevent, is it properly operating the equipment? Are they properly maintaining it? Taking care of things, battery room floors, cable management, and then if there is a lifting beam used, a staging stand to protect that lifting beam. Tons of blogs on our websites covering all these different topics, from safety requirements to the different type of technologies that are out there, and even a knowledge base that helps compare some of the different solutions when you're looking at automated, for instance, automated versus manual wash equipment, or side extraction versus overhead extraction. So all this type of information is found on bhs1.com. Okay.
So thank you so much, Trent. I think that was a great presentation covering almost all the aspects of battery handling. And thank you so much for taking us through this very, very insightful presentation.
You're welcome.
So we have got quite a few interesting questions, and it would be great if you could help our audience get their answers.
Sure.
So one of the first questions is what should be prohibited in the vicinity of battery rooms? And so that's the first question. So what should be prohibited? What should not be there in near the battery rooms? And the second part of the question is, can metal jugs be used for filling distilled water? So these are two questions that we have got from the same person.
So as far as prohibitive items in a battery room, of course, you're not going to keep any type of break room, resting area for the employees, any type of lunch cafeteria, snack area. And probably the biggest danger in a battery room is any type of open flames. That you have to be very careful, especially when working around batteries, regarding having open flames. Now, and that is due to the hydrogen being off gas from the batteries, because it can be explosive if it does build up in certain little pockets underneath the battery stands themselves. As far as a metal watering tank, that is fine. The bladder tank that we did show earlier is actually built of a metal construction with a rubber diaphragm in it. So using and that's a good point too on the water, and actually miscovering that, is the water filters are needed in order to provide that deionized water for the batteries. It's very important to have a filtered distilled type water when refilling the batteries, as if there are minerals in it that will deposit on the plates and can actually reduce the life expectancy of the batteries, or even the capacity of how much charge they have left. But right, metal is fine. Yeah.
Okay. Thanks, Trent. So the next question is that any company would have different types of batteries based on the equipment mix that they have. Now, when a battery system is designed, is it flexible enough to accommodate different sizes, or is it like one compartment for a particular battery and it's not really flexible in that sense? So basically, can a common system be there for different types of batteries?
So yes, so there's a few different ways to tackle it. I'll just tell you, on the BHS side, we believe in having rollers in our battery stands versus slide strips. Rollers keep the maintenance on the equipment down quite a bit versus having slide strips, which are harder on the equipment to push and pull the battery. And the reason I tell you that is, in some of the stands, when you have what's called a slide strip, they have plastic strips below that the batteries actually go on. Those can be adjustable at times. So over the change of the course, you could take a battery that maybe, say it's a reach truck like we have shown on the screen right now, and instead of storing those, you want to store a pallet jack, and those slide strip stands can actually be moved to accommodate those smaller ones. Now, really what actually happens is 5 to 10 years down, when you make that change, the corrosion on the stands and stuff from the battery acid makes it to where it's almost impossible to adjust them. So that's kind of tells you about the adjustable stands and then why we believe in rollers. The other way to design it is, of course, battery rollers or stands can be had in different sizes depending on the size of the battery, but a common thing to do is just go with the bigger one. So an instance with fleets nowadays is we know a lot of people maybe be using what we call the 36 volt 17 plates, which would be right around let's say 19 inches or so, but they might go to a bigger one in the future. We go ahead and build in those larger battery stands now, and then they can always go to those later. The other thing that happens is with a sit down type stand is actually comprised of 2 separate rollers. So for instance, later on they wanted to change that into maybe stand up batteries or pallet jacks. The stand is already built to accommodate either 1 big battery or 2 smaller batteries.
Okay, yeah, understood. So the next question is, though you covered it in your presentation, like you spoke about which count of batteries is suitable for vertical pull out and which count is suitable for horizontal extraction. But the question is again being repeated that can we just summarize in terms of quantities that which quantity of batteries qualifies for which type of battery handling system? Just a broad summary.
So, and the difference between side and overhead extraction is going to be totally dependent on the truck. So if your trucks only allow side extraction, then you're going to go with a side type extraction system, or if you go with an overhead, that. But as far as the counts of the fleet and which one's best, a good guideline, and I like to use with in one of my primary roles is dealing with the operator board battery extractors, is any type of battery count that's under 20 or so is going to be better suited being handled by what we call the transfer cart systems. So that's the hydraulically powered ones that are mounted to pallet jacks or the ones that the operators push along. Any typical operator board battery extractor has a lot of space that's needed just for the machine to travel, and you're not saving a lot of space when you're in counts between 1 to 20 batteries. So a very good rule of thumb there. And then of course, as you go up above the 20s, you can still use the transfer cart systems, and now you're into the operator board extractors, but more operator preference as those transfer cart systems will start to take up a lot of space at that point.
Right. And so the next question is, what type of maintenance requirements are there for a battery handling system? Like in what frequency and what type of maintenance would be required in handling these systems?
Gotcha. So speaking of our equipment, because I know our exact maintenance intervals, but all of our operator board battery extractor systems are now designed to be able to be serviced at a 250 hour as far as oil changes and some of the major maintenance. Other than that, on the weekly side, there's just going to be a few grease fittings that need to be done, and that's going to apply across the board on all the equipment. So on a weekly basis, any grease points are going to need to be lubricated, and then the equipment needs to be overall inspected and maybe at least wiped down. It is handling batteries which get dirty. As we know, they do have acid on, so it is very important to keep the metal components of that equipment clean on a weekly basis. And then depending on the use, the quarterly, yearly basis, performing oil changes on the hydraulic pieces of equipment.
Right. So there is a follow-up question on that with all these good maintenance practices, what can be the life of a battery handling system? A typical life, 5 years, 7 years, 10 years, what can be a life?
So we design our equipment, and a lot of the industry follows suit as well, to exceed 10 years of life. Now, that's a good mid-range number because depending on how it is maintained, I've seen the systems make 10 years and then they need replacement, but there's also systems out there that can go 20 or 25 years. Just really depends on the maintenance of it, but you'll at least should expect over 10 years out of your battery handling equipment.
Right. One of the topics that you covered, and this has also come up as a question again, that the flooring requirement you spoke about an epoxy flooring in a battery room. So any particular guidelines for flooring, that why should we have epoxy or any other flooring would be required, something like that? Anything on flooring for battery handling rooms?
Sure. So in the operator board extractor systems, it's a little bit more key to it, but it does apply to transfer carts as well. So besides protecting the floor from acid spills and stuff, another thing that's common out there is to do a harder type concrete on top of the existing warehouse floor and then the epoxy. As you can imagine, on the operator board systems, they're constantly traveling that same area and they will wear down that floor, causing degradation. Same thing with the transfer cart systems. It is a constant area in there where they are traveling. And then probably the most important thing that I don't always see when epoxy floors are installed in battery rooms is making sure there is some type of texture to that floor. You do not want a very slick, smooth coating in there, because one of the main operations of maintaining those batteries is washing them and watering them. And as that water spills on the floor, it can present a definite hazard. With that being said, too, it's very common for people to take that into consideration and then incorporate drains into the battery room. We believe drains are not a good idea in the battery room. It's better to make sure you have a slick coating on the floor and keep all spills minimized. And the reason being is now you have a drain that if there was a battery acid spill or something, gives a direct feed back into dumping that lead acid water mixture back down into the sewer system.
That explains that in detail. The next question is about the typical location of a battery handling room. Should it be in the corner of the warehouse or should it be outside the warehouse or a plant? Are there any guidelines on that?
Yeah, and that kind of falls in line with, you need to know what the traffic pattern is. Where are the trucks most commonly being used at that the system's going to be changed, and try to keep it close to those. Corners of warehouses are very common, especially in between two dock areas. That's probably where I see a majority of the systems. Central locations can be done as well. It's usually a little bit harder to get the electrical there, but you want to keep it close to where majority of your forklifts are. You do not want a fast changing battery operation, but it takes 10 minutes to 20 minutes for the forklifts to get there. They can be installed outside. They just need to be protected from the weather. But once again, you still want to make sure that's a easy area for those trucks to be able to get to the battery room, because as we all know, the biggest thing we're trying to do is keep those forklifts operating and moving the product that the different businesses sell. So it's important to minimize that time that they're trying to spend getting a battery changed.
Right. That's well explained, Trent. So we have got two similar questions. Both are talking about the ROI, the return on investment. So generally in lower fleet sizes, people are using manual trolleys for changing over the battery. Now, what is being asked is that how do we get the payback period when we upgrade to a system which is more automated, operator on board, or maybe ATC? How do we get that payback period or the return on investment that we have? What are the aspects that help us?
So a few different things you're looking at when you're looking at the ROI on these type of systems. So the changeout time is going to be a big crucial one. So if you're going from a gantry system or even a manual push cart, you're looking at how much labor time are you saving just in the operator, how much quicker is he going, as well as getting that forklift turned around. As we were just talking about on the previous question, it's important to get that forklift, the battery changed, and get it back on the floor and working. So there's one aspect of the ROI, is your labor charges for your person standing there and loss of production, and as well as the person performing the change. The other main thing to look at is floor space. And that was kind of ties into that question regarding the 20. So when you have these multi-tier systems that can store batteries at the taller heights, you're looking at how much warehouse space are you saving. So if I go and I take up we'll say a 1,500 square foot area with a operator board type extractor system, but that same area for a transfer cart or even a gantry could be 3,000 to 4,000 square feet. So you've recouped all that warehouse space, and you can add additional racking, storing more product and increasing productivity of your business. So those are the two main things to look at on the ROIs themselves.
Right, understand that. Now, the next two questions are typical of considering the Indian conditions. So the first among that is that how is it the heat and humidity? Is it going to be a factor in the working of a battery handling system? And so that's the first question. So if you could first answer that, then I would put on to the next question.
It's not, the heat and humidity is actually not a problem with the battery handling equipment. They are designed to be able to handle that. The only time you usually see an issue with battery handling equipment is in cold conditions when there's an extreme buildup of moisture on the batteries themselves. But the heat and humidity is not a problem with that.
Right. And the next question related to India is that there are quite a few regions where there are sometimes power cuts which happen. Now, one such situation is faced. So are there any precautions to be taken, or will it have an impact on the battery handling room in terms when there's a power cut?
No, and as far as the equipment goes, there's no real complications. The equipment will come back online. The biggest thing I would check would just be watching the chargers. As a battery, power cuts out and then comes back on to the chargers, you could have a situation where all your chargers kick on all at once. So to make sure you have enough electrical power in there to handle that, and then also making sure that the chargers that we're charging and still in progress of charging, that they are able to turn back on and continue their cycle, so you're not left with batteries that are without charge. Any type of safety issues, once the power goes out, it takes care of those. Hydrogen's not built up anymore once it stops charging, and then there's no electrical danger either with no power. So,
right. So the next question is from a industry which is really growing in India, is from a cold chain. What sort of precautions, or is there a special system for handling batteries which are used in equipment moving in freezer rooms or chiller rooms, minus 25 degrees? So is there any special guidelines for those batteries?
So the only main thing, and that we kind of touched upon, is watching the extraction method that you use. When dealing with the cold storage ones, it's best to use a magnet type extractor or extraction mechanism with it instead of the vacuum cups, due to the condensation and the froze and the ice that will sometimes develop on the outsides of the batteries. Ensuring that area. Now, this is a situation where we will sometimes see drains in the battery room, especially in what we call the truck changeout area, which is where the truck parks. Very important, as that truck pulls into a battery room, which are typically not in the freezer, that truck could have some condensation and liquid coming off of it. And so you want to make sure that there's either a plan to keep that mopped up, or that there's a drain located just where that truck pulls up and parks in order to deal with it.
Right. The next is interesting question. Can mobile phones be used inside a battery handling room? Is there any threat with that?
There's not a problem, but with all the batteries, and we see it on a lot of our units, our newer extractors actually have cell phone signal on them. And one of the biggest hurdles is that once you get down in the aisle with all the batteries on both sides, it's very good at blocking some of your cell phone signal. There's no danger or anything, but it is harder to get signal while you're inside the actual battery room area if you get really close to all those batteries.
Right, right. So the next question is again very interesting, that whatever we have seen so far is about handling of lead acid batteries and the chargers. Is there anything which is happening for the lithium ion batteries and chargers as a trend, or is there any solution for that? We know that we don't need additional batteries for lithium ion batteries, but for the chargers itself, is there any trend going on which BHS is working on?
There's nothing exactly special other than dealing with the new charger design. So even in a lithium application or what we call park and charge or fast charge applications too, is just making sure you have the right type of charger stand for those lithium chargers. Now, you did say a trend, and sorry, it just came to me, but one of the biggest things that's coming out is the cables are actually getting quite a bit bigger in diameter. So they're starting to weigh a lot more. So one of the few newer things, especially VHS has been working on, is a stronger method of holding those cables up as the weight has increased. So definitely ensure that the system that holds the cables up when they're not in use is strong enough to handle that additional weight.
Right, right. So I think we have this last question, which talks about in terms of manual handling versus this handling through systems. You already explained that, but somehow this is repeated again, that what is the exact advantage that we get immediately? Like you spoke about that you're saving the labor cost, you're saving the space by going higher. But in terms of payback period, will it be like 1 year, 2 years, and will it be related to a number that people should look at? I think people are just trying to get their head around what type of numbers they should have before they start considering this system.
Understood. So if you look at a comparison system between what we typically look at is the transfer card based ones, of course, discussing batteries over more than 20 of them versus the operator aboard. Whenever we have ran ROIs for that based off numbers, the payback period is typically within 1 to 2 years. The main advantage you're also getting, that should be said, between manual and even automatic, so versus a manually transferring a battery by hand using carts and pushing it versus the powered solution, is worker injuries. Now we're not worried about the workers with those heavy weights doing it, as well as pushing batteries around that can weigh 2,500 pounds on a manual type solution. But typical, what the ROIs come out at is payback within 1 year. Some of them take up to 2 years depending on the application.
Right. I mean, that gives a good idea. Trent, thank you so much. I think it's been great having you on board to this platform, and you've really answered the questions very, very accurately. And I think most of the doubts have been completely cleared. If there are any more questions which come back to us post the event, please allow us to approach you to get answers to those. So once again, thank you so much. And to all the audience who has been a part of this event, thank you for your time and coming to attend this insightful session. One last thing before we end, there's a feedback form which has been posted in the Q&A section. We would request you to please fill up that form and share that information with us. It will really help us to further better our content, the presentation, or anything that you want to give us a feedback on. And of course, if you want us to cover any additional topics that are of interest to you, please feel free to approach us. With that, we would like to bring this event to a close. Thank you again, all of you, so much for being a part of this event. Thank you.